Welcome to this explainer. Okay, today we are literally cracking open the playbook on modern manufacturing and sourcing strategies. We're looking at a massive, everyday decision that procurement managers face: Waterjet versus plasma cutting. It's the 2026 Procurement Guide, and I'm absolutely pumped to walk you guys through this. So let's jump right in.
Okay, let's dive into this. When you're looking at a quote from a cutting supplier, ask yourself, are you calculating the hourly rate or the true cost per finished part? Because listen, if you're still just looking at that hourly machine rate, you're probably falling into a pretty outdated trap. Today, we're going to completely rethink how we evaluate the actual true cost of procurement. Here's our roadmap for today. First up, we'll go beyond the hourly rate. Then, number 2, the physics, hot versus cold. Third, final part quality realities. Fourth, total cost of ownership. And finally, number 5, your 2026 sourcing strategy. All right, kicking things off with Section 1, beyond the hourly rate. So the global supply chain has fundamentally shifted, right? It's really no longer just about picking the absolute cheapest machine in a vacuum. You've got to look at the whole picture. To evaluate suppliers effectively today, sourcing leads have to look at 3 new drivers: energy efficiency, automation compatibility, and material versatility. This is a huge strategic decision. You really can't just look at the initial invoice anymore. You have to see how this cutting tech fits into the much broader, modern ecosystem of your production lines. Moving on to Section 2, physics, hot versus cold. I am super excited to get into this part because from a sourcing perspective, the biggest commercial difference between these two technologies actually starts with the pure physics of the cut itself. Now, before we compare them, we absolutely have to understand haze, or the heat-affected zone. This is the area of the base material that gets altered by thermal stress during cutting. Think of it kind of like a severe sunburn on the very edge of your metal. It's this critical, often completely invisible variable that can entirely dictate your manufacturing process.
And this brilliantly illustrates just how stark the contrast really is. Waterjet is a cold process. It uses a high-pressure stream of water mixed with an abrasive, usually something like garnet. And because there's literally no heat involved, there is zero heat-affected zone. None whatsoever. Plasma, on the other hand, well, it's a hot process. It uses an accelerated jet of superhot plasma, which inherently introduces thermal stress right into the material.
Which brings us to Section 3, final part quality realities.
Okay, so we've established the physics. Now, let's connect that heat-affected zone directly to your sourcing strategy. As the industry consensus points out, if the project involves heat-sensitive materials, Waterjet is often the only viable choice, despite the higher per-hour machine rate. For industries like aerospace, for medical components, or, if you're working with specific plastics and high-grade alloys, the physics completely dictate your procurement choice. You simply cannot use a hot process without totally ruining the material's integrity. Now, what's really interesting about this slide is how the procurement logic just snaps into focus. Look at material versatility. Waterjet handles virtually anything, while plasma is strictly for conductive metals. Then consider precision. Waterjet gives you incredible tolerances. We're talking plus or minus 0.003 of an inch. Compare that to plasma's standard 20 thousandths. But wait, factor in cut speed and thickness. Plasma is insanely fast and absolutely perfect for 1/4 inch to 2-inch thick steel. It's a really stark trade-off between absolute precision on one hand and raw, blistering speed on the other.
And when we really zero in on final part quality, well, here's the reality. Waterjet gives you this beautifully satin-smooth edge that requires zero finishing. Plasma, mostly because of that thermal stress and the heat-affected zone we talked about, leaves a rougher, hardened edge. It almost always needs secondary grinding and deburring, especially if that part requires welding down the line.
Let's move into Section 4, total cost of ownership. All right, it's time to transition from the physical realities of the cut straight to your bottom line. How do these factors actually hit the budget? Well, 50 to 70%. That's a massive, massive chunk of operating expense, right? And it represents exactly how much of a Waterjet's cost goes purely to the garnet abrasive used in that water stream. So yes, Waterjet machines are undeniably expensive to run. So the crucial point here is understanding what we call the Waterjet premium. Yes, for sure, the operating costs are high, but they're dramatically offset because the cut is final quality. Think back to our focus on that zero heat affected zone. Because there's no nasty slag to chip off, no edge discoloration to polish away, you are saving a ton of money on downstream labor. On the flip side, we have the plasma value proposition.
Let's be clear about this. Plasma is the undisputed workhorse for the structural steel and shipbuilding industries. The initial capital expenditure, your CapEx, is significantly lower than a water jet of the same table size. If your tolerances are relatively loose, your material is thick, mild steel, and those rougher edges are perfectly fine for your application, Plasma's extreme speed offers an absolutely unbeatable ROI.
Finally, let's wrap up with Section 5, your 2026 sourcing strategy. So, we've covered the physics, the quality, and the costs. Now, here are some actionable strategies tailored to your exact manufacturing profile. If you're a brand or an OEM making high-precision parts, Waterjet is your go-to standard for exotic metals, ensuring consistent product performance without altering the temper. Now, if you're a bulk buyer or wholesaler dealing with structural components, Plasma is your logical choice for sheer speed and massive volume. Interestingly enough, if you are a direct-to-consumer or e-commerce seller, you actually probably prefer Waterjet. Even though it's a bit pricier per hour, the cleanliness drastically reduces secondary finishing, which is just perfect for smaller batches of consumer-facing products. Now, if you're evaluating a provider, you need a highly practical checklist to make sure they meet modern 2026 industrial standards. You should be asking, are they using advanced nesting software to minimize your material scrap? What's their pump tech like? Is it direct drive for energy efficiency or an older intensifier? If you're going with Plasma, are they using an X-definition gas console for cuts that actually rival laser? And, absolutely crucial for structural integrity, can they provide MTRs or material test reports for true material traceability?
Let's move to and see how this builds into your real-world requests. To eliminate hidden costs, you've got to be specific in your RFQ. Step 1, specify the edge finish. Don't just say cut it, say ISO 9113 range 3, or explicitly state no secondary grinding required. Step 2, request a test coupon sample cut so you can observe the kerf and taper for yourself. And step 3, plan your logistics. Especially if you expect plasma parts, because they'll likely arrive with a light layer of oxidation that you'll need to clean before you can paint or plate them. So, what is the ultimate 2026 strategy here? Well, as high-power fiber lasers compress the market, the absolute smartest sourcing leads are doing exactly this. Split your bill of materials or your BOM. Use plasma cutting for your internal structural ribs, where volume and cost matter the most. Then use Waterjet for the external, visible components, where that final part quality and having zero thermal stress are absolutely paramount. It really is the absolute best of both worlds. Which leaves us with one final critical question. In 2026, are you ready to split your BOM for maximum ROI? Listen, don't let outdated hourly rates hold your operation back. Understand the physics, evaluate those heat-affected zones, demand top-tier final part quality, and really optimize your supply chain. Thank you so much for joining me on this explainer, and I'll catch you on the next one.